Okay, I said that you needed to have 4x4. But reality says we don't always have a 4x4, do we? So the question is, what do we do if it's not square? Here we have a straightforward example. I've got 1, 2, 3, 4, 5 people, 4 activities. Which in reality happens more often than 4 people and 4 activities. Any suggestions what we could do in order to apply the algorithm, but I need it to be in a square matrix?
Add another task and make it 0.
I'm going to add another task. Because if I make another task, that's great. But I don't ever want that task to be chosen, because it doesn't exist.
Yeah.
So this is a minimise array. So what I'm actually going to do, I'm going to put a dummy task on the end. But I'm going to set a randomly big number. Because your algorithm will minimise, these numbers will never be chosen because they're bigger than everything else.
Yeah.
Now, choosing it, here they've chosen it 35, 35 is the largest element. I was always taught double the largest element. Pick a big number bigger than the largest element just to make sure that it never gets chosen. Okay, so I don't like the fact that it's 35, I'd have done at least 40. It doesn't actually make any difference, but it just means you get big numbers on there. And then of course, you can apply exactly the same algorithm. So you subtract the smallest, look for how many lines it takes. So the principle is the same, but you've just got this extra dummy row on the end. And if we just quickly work through this one, we'll reduce the rows. Notice that the dummy column stays massive as we reduce the rows. Then they're going to check for an optimal solution, but I would never check at that point because it's never going to be one. You're wasting your time. Reduce the columns. They can't be reduced anymore, so we've actually only got 2 columns to be reduced. And the dummy column on the end. But notice even after reduction, the dummy column is never going to get picked for our solution. See how many lines it now takes. How many lines do we reckon it'll take in this one? 4. I think it'd take 4 lines at this stage.
Yeah.
Yeah. So it's 5 by 5, so that's not optimal because you've only used 4 lines. So we find the smallest uncovered element, which is 1. Subtract 1 from everything and add it to the ones that are covered twice, so we can add it to those ones in the middle. And then take the lines off and look, see how many lines it now takes. One, 2, 3, 4, 5. I can do it in 5 columns. I think that might actually take 5 now. There you go. So because it takes 5, that's making an optimal solution, and then we can find our solution from there. And in this case, the solution is that, and then you go back and you look at your original table. Now, Kate's solution came out as the dummy. So Kate's not getting a job. She's the dummy. The other people will get a job. Is that okay?
Yeah.